let's see some examples where we have a leading coefficient. So previously, we were just completing the square where it was x squared plus bx plus, and then we figured out what to fill in there. Well, if there's a leading coefficient where a is not just 1, what we're going to do, what is a person to do, is divide both sides. When you're solving an equation, you're allowed to do anything you want as long as you do it to both sides of the equation. So I can just divide both sides if a is not equal to 1. So by whatever a is, let's get rid of it. So here our leading coefficient is 2, and I don't want it, right? We talked only about what to do if a is 1. So to get rid of this 2, we just divide by 2. But I have to divide every piece of both sides by the same thing, right? We still have to use all those rules of equations. I can't just do it sometimes, we gotta do everything. So what I get is x squared plus 2x minus 3 equals 0. Now we are solving by completing the square. I am already looking for like factoring and maybe it's easier that way, but that's not what we're doing. So we're gonna move the 3 to the other side, add 3 to both sides. So it becomes x squared plus 2x plus something equals 3 plus something. I'm gonna add some number to both sides to complete the square. And what that number is always b divided by 2 quantity squared. So that's 2 over 2 squared, which is just 1 squared is 1. All right, and the reason we do that is because now x squared plus 2x plus 1 is the same thing as x plus 1 quantity squared. And on the other side, 3 plus 1 is 4. So we can square root both sides as long as we remember that plus or minus. So we get x plus 1 is either positive 2 or x plus 1 is negative 2, right? That's what that plus or minus does. Sorry, I'm crooked there. So square root of 4 is 2, positive or negative. Subtract 1 from both sides, and we get x is 1 or x is negative 3. So those are our two solutions. We can put them in curly brackets to join them together here. And both of these we could check by plugging into the original equation. All right, well, that's what solving by completing the square looks like. Another check, I guess, would be solve by factoring and make sure you get the same answers. That would work too. Let's try a couple more just to see what this looks like. So again, first step needs to be get rid of this leading coefficient. Divide by 2, divide by 2, divide by 2, divide by 2. If it's an equation, I'm always allowed to do anything I want as long as I do it to every piece of both sides. So now what we get is x squared plus 12x minus 3 equals 0. I'm going to add 3 to both sides because I don't want that as part of my completing the square. X squared plus 12x plus something equals 3 plus something. To fill in that something, I need to take this b divided by 2 and then square it. 12 divided by 2 squared is 6 squared, so 36 is what needs to go in this blank. And the intention of this is to write the left side as something squared. And then on the right side, it's going to be 39, 3 plus 36. And what goes here is always x plus, and then that b over 2. Before we squared it was just 6, because now if I square x plus 6, we get x squared plus 12x plus 36. Okay, square root both sides, making sure you put a plus or minus on there. So I get x plus 6 is positive or negative square root of 39. Check to see if there's any perfect squares that go into 39. I don't see any, so we just subtract 6 from both sides. So x is -6 plus or minus the square root of 39. Or in curly brackets, it'd be -6 plus square root of 39, or -6 minus square root of 39. And again, oh, sorry, I'm off screen there. You could get decimal versions of these in order to check. You could check with Desmos. There's some options. But this is what solving by completing the square looks like. All right, let's try another one. 2x squared plus 6x minus 1 equals 0. If I have a leading coefficient here that's not just a 1 out in front of the x squared, I need to get rid of it. And in an equation with an equal sign, we can always just divide everything by 2. Now, these previous two examples were sort of nice because everything divided evenly, but it doesn't really matter whether it divides evenly or not. We need to have that leading coefficient be a 1. So what I mean by not dividing evenly is I have a 1/2 here. So what? We like fractions, that's fine. So I'm going to add 1/2 to the other side. X squared plus 3x plus something is 1/2 plus something. I'm going to add something to both sides to make the left side a perfect square. That's the goal. What we have to add, I didn't give myself room like I have been here. I'll just do it over here. What goes in these two blanks is always b divided by 2 quantity squared. So our b is 3. 3 over 2 quantity squared is 9/4. Oops, sorry, I'm in a weird shadow. All right, so 9/4 goes in both of these. 9/4, 9/4. But what the perfect square is just the x plus 3/2 quantity squared. So once we square the 3/2, that's where the 9/4 comes from. On the right side, we're going to need a common denominator. So that'd be, I need to multiply by 2 over 2 to get this to be 2/4 plus 9/4. So on the left side, I'm getting 11/4. Let's take a moment here to check our work. So b divided by 2 squared goes in these blanks. B divided by 2 ends up in this binomial. And then I got a common denominator of 4, added the numerators, looks good. Okay, this gives us a method of solving because as soon as I can get it as one thing squared, I can just square root both sides to get rid of that, as long as we put a plus or minus there. So now the square root undoes the squaring. So it's x plus 3/2 equals plus or minus the square root of 11. And always think of the top and bottom as separate square roots. So square root of 4 is just 2 in the denominator. Last thing we need to do is subtract 3/2 from both sides. So x is -3/2 plus or minus the square root of 11 over 2. Or if you want it to look like a quadratic formula problem, you can put it all over one fraction. -3 plus or minus the square root of 11 over 2. Or you can, write it out in curly brackets. When you're typing this in WebWork, if you're viewing it as one fraction, make sure you put parentheses around the top because there's more than one piece to it. Or -3 minus square root of 11 over 2. So with all quadratic equations, we should expect to get 2 solutions most of the time. Completing the square just gives us a different way of solving it other than factoring or quadratic formula.